Yeah. Like between 10 and 20%. Mhm. And the thing that's screwed up about this is every student practically takes algebra 2 in high school. So then the thing is same class. So that means the person didn't learn in high school, had to learn for like multiple years then. Probably teacher's fault, to be honest. And then next thing you know, they took it in college, had difficulty learning it then, because obviously they didn't know enough when they went to the next school. Yeah, it's not good. All right, enough babbling. Okay, so you do have to complete your exam as we said previously, right? So make sure you do that, okay? I may come up with a way for you to possibly, no, we'll see. All right. So then take your exam. You have to do the review quiz also. Again, you can do the review quiz multiple times. It counts for a grade. Does that understand? Counts for lots of homework assignments. You have to do it. All right. I will curve the review quiz score at the end, probably a little bit. All right. The again, the review quiz is very similar to the exam. Does that understand what I'm saying? Very similar. All right. So it's going to pick different questions, fine, but they're going to be on the same topics. Does that understand? They might not all look the same, even. Like, you get question 2 one time, you get question 2 another time. Like, even if it's on the exact same topic, the questions might not look the same, just like in your homework. Does that make sense? But they will be almost identical to your homework questions and all of that. All right. So it's the same stuff you've already done. Does that understand what I'm saying? All right. If I were you, first exam's not so bad, but it's good to get off on a good start. If I were you, I would take the review quiz at least twice. Does that make sense? Yeah, at least twice. All right. Because every time I see a student take the review quiz, right, they'll get no, and you have a time limit on the exam, but it's again, it should be enough time. All right. But the every time I see a student take the review quiz and I see a student like let's say get a 65, I'll see them get a 57, 60 on the test. You know what I mean? You get a little bit less usually. Does that make sense what I'm saying? You make a mistake or whatever, or you get a new question you haven't seen. Does that make sense? All right. But you take it a couple times, then I see the person score more or less kind of target. Does that make sense? Question, sorry. Yeah, you can use notes. I don't care. Yeah, sure. But I'm warning you of one thing. All right. Once we start getting towards the end of the class, the exams are going to be cumulative as we go through the course. In other words, exam 2 is going to contain information from exam 1. Exam 3 is going to contain information from exam 1 and exam 2. Does that make sense? All of this is in preparation for the final exam. Does that make sense? All right. Because sometimes I see students not do so well throughout the semester on some things, but then they put some things together at the final and then they do a lot better. And I'm like, well, you showed me you know the crap. So, you know, let's see what we can figure out. All right. But the thing is if you're not if you're constantly relying on your notes all the time, right? It's hard for you to understand the concepts really because you're not really like recalling them. You're just reading them. Does that make sense? You don't understand it necessarily. You're just using the information that's right in front of you. Does that make sense? Once you get towards the end, then there's more crap, obviously. And then this particular set of topics that we're doing right now, there isn't like a cookbook for it. Does that make sense what I'm saying? There's some formulas, but we have to understand the formulas and be able to apply them. Does that make sense? And then, so as long as you're trying to understand it as you're doing it, you're going to keep seeing more of this over and over and over again, and you're going to be able to understand more and more and more as you go through it. But if you're just constantly relying on the notes, then you're not building on the last thing, and then it sometimes becomes a problem. Does that make sense? What I'm saying? But again, a lot of this stuff keeps getting reinforced, so you will have a chance really to relearn stuff as we go through. Okay, and but the first exam is definitely the easiest one. Does that make sense? All right. Usually people have a little bit of difficulty with the second one because it's probability stuff. But then usually by the third test, people are usually good with that. Does that make sense? All right. And then everything that we learn pretty much from like the third test on is all crap that we can do in the calculator. So then you just have to kind of know where to go and then what does it mean? Does that make sense? This crap, this thing's people get annoyed with this stuff. All right. But this is honestly, again, what I feel like when I was in school that taught me fractions. Does that make sense? All right. So first we start talking about like probability. All right. This is definitely my favorite part, but I think I'm a weird person. So all right, so you're like, yeah, you are. So then so then the you're like, yes, you are. All right, so then no, I know I'm weird. This is shit. I do math competitions. So there's something wrong with me. All right, so yo, I got when I was a kid. All right, I don't like fantasy football like a lot of things that people play because it's the other version I like to play. I like the one where you play salary cap and you have to buy the players and stuff like that, and then you don't not the draft. I don't like when you do draft. So then the thing is like I did this one when I was a kid. All right, there was a million people that played it. This was back when the internet wasn't so crazy. Like people didn't know how to like do a lot of stuff. So a million people were playing the stupid thing. I was so excited. I got 72nd place. I got a T-shirt. I beat a million. I beat like almost. I beat over a million people though. But I beat almost everybody honestly. But I remember I got anyway. Whatever. You don't know the players, so it's not going to make any difference. But all right, probability. So what does probability mean? So like we have something that we refer to as the sample space. All right. So what the heck is that first? Actually, let's define an event first. All right, an event is any possible set of outcomes in the sample space. Okay, what the hell is the sample space? Sample space is the space or set, whatever you want, of all possible outcomes. Okay? So in other words, there's all these different possibilities of things that could happen. So we have so we define random variable. A random variable is a variable x, right? Generally, I write xi, okay, to indicate like different events that are possible. Does that make sense? So like x1, x2, x3. So a random variable is a variable xi such that the outcomes of the variable can only be defined by chance. This is in opposed to something called a deterministic variable, which is a variable that can be determined or measured. So an example of a random variable, let's say like let xi be the number of heads after a coin flip of a fair coin. Deterministic variable, an example is something like the height of the next person, the height of a person next to me. But this is in contrast again to another example here of a random variable, though, would be the height of the next person who walks in the room. All right, like we don't know who's going to walk in. Does that make sense? So their height we can consider to be random. Does that make sense? All right. All right, so sample space is really all these little events. So it's like x1, x2, x3, x4, x5, x6, whatever. Lots of events here. Does that make sense? All of these different possibilities. All right. Does that understand what I'm saying? Maybe x1 might be the same thing as x2. They could both be like brown hair or something. Does that make sense? All right. The Then there's some collection that we start taking. So then we define the probability of event A. We write it like this. This is phrased P of A. This is the chance that event A will occur. We calculate this by saying we count the number of outcomes favorable to event A, and we divide this by the total number of possible outcomes in the sample space. Does that make sense? Does that make sense? Um, the probability of event A is said to be the long run frequency, relative frequency of any possible sample from the sample space. All right, so what do I mean by this? So like if I keep sampling and get n gets larger and larger and larger and larger and larger, does that make sense? Right? Then I'm gonna pick things randomly from here, right? Eventually I'm gonna be able to select everything. Is that correct? And if I looked at the relative frequencies each time when I did that, right? So first I look at the relative frequency, I see what's the chance I got. Like I get some sample, I see how many of these things are in it. Does that make sense? I count the number of those that are in it, and then I divide by the total that I just had. And I just keep doing that over and over and over again. Does that make sense? Does that make sense? If I do that, and you imagine that you could do that forever, yeah, like an infinite amount of time, you just keep grabbing stuff. Does that make sense? Then you did it forever, we call that the probability. Does that make sense? You do it for your individual sample, right? You look for some class, you count the number of things in the class, you divide by the total, right? That's called the relative frequency. But if we're able to do this relative frequency and do it with an infinite size sample, right? Then we call that now the probability. Does that make sense? Question with this so far? What have you with any of this so far? Do you know what I mean by deterministic? Do you understand what I mean by this? Cannot be measured. Specifically cannot. I should have probably said cannot be measured. But random effectively means it can't be measured. Does that make sense? You don't know what the hell it's going to be, right? There's no meter stick you can put next to it. Does that make sense? You get what I mean? Either we get heads or we get tails. I don't know, right? What the hell am I measuring? Does that make sense? But like, I want to measure your height. Yeah, we can measure your height, right? Does that make sense? Question? Sorry? Me? No. I'm 6 feet tall. So you need glasses. No, I'm kidding. I'm joking. I'm joking. I'm joking. So like the you guys still copying this? You need this? Any question with any of this stuff? Indira? This stuff I'm writing is not very special. It's pretty much the same thing that's gonna be written in the book. Book will probably write a little bit better. I'm just not writing everything because I don't really think you need it necessarily. You understand what it means? You're gonna understand every single definition they start explaining about it. Does that make sense? They write like 3 different definitions, but it's all the same bullshit. Does that make sense? So I don't usually do it. All right. Which of the following cannot be a probability? Any idea here? Kalani? You say B? B is correct. Why do you say B? You're right. He just raised his hand. I don't like you because I don't like people with glasses. So like the no, he just raised his hand. So the no, you're wearing my orange and blue. I love it. So the go Gators. All right. So the by the way, that's another thing. You guys are going to finish this program, and then any school in the state of Florida pretty much has to accept you. It's a public university. Does that make sense? All right. There's a waiting list at some of them. So you just have to apply the right way and do it. But they will accept transfers. Does that understand what I'm saying? So you're going to have an opportunity to go to UCF, FSU, University of Florida, whatever. There's tons of universities. All right. Amongst others. You can transfer out of state also if you wanted to. All right. I don't really recommend that necessarily because honestly, schools are pretty much the same crap. But the unless you want to leave, obviously. But you have an opportunity to pay for things pretty cheaply in Florida. And I'm just saying, if you get, a chance, try some of these other ones if you think that will fit for your stuff. All right. 5/3. All right. So what can we say about a probability? Well, I guess we can say the probability of event A is bounded between two numbers, 0 and 1. Why? Sorry? That's correct. So like P of A, right, is the number of events in set A divided by the number of events in the entire sample space. Does that make sense? Does that make sense what I'm saying here? All right. This has to be less than or equal to the number of events in A. The most it could possibly be is all the crap that's in here. Is that right? So this numerator has to be less than or equal to whatever's in the denominator. Does that make sense? So then this n of s divided by n of s would be 1. In other words, it must be less than or equal to 1. Is that correct? Right? What's the chances that you're blonde haired and blue eyed or whatever, right? Well, then we have to count the number of people that are blonde haired and blue eyed out of the total. Is that correct? Well, if everybody is blonde haired and blue eyed, we would get 100%. Is that correct? We can't get anything more than that. Is that right? Then how do we define what the smallest thing is going to be? Denominator is still going to be this. How do we explain what the numerator is going to be? What's the smallest possible? We can have 0 events that are favorable. Is that correct? If 0 events are favorable, then this would, of course, equal to 0. So the probability of any event must be bounded between 0 and 1. Could be 0, could be 1. Does that make sense? 0, your book says that it's an impossible event. That's not really true. So we're going to cross that out, okay? It's an improbable event, something that's very unlikely to occur. Does that make sense what I'm saying? This, your book says, is a certain event. Certain is wrong also. It's an extremely likely event. Does that make sense what I'm saying? All right, I don't really, yeah, whatever. I don't think you're going to be able to answer this question, but can anybody give me an example of an event in some situation? Oh, wait, let's first just do some simple example first, okay? So let's say we define the random variable xi to be the number of heads in one coin flip, okay? Let's do two. One's too obvious. Two coin flips of a fair coin. I assume it's a fair coin. Does that understand what I'm saying? You should assume fair unless stated otherwise. All right, so then this, all right, now we haven't done very much yet. So the only thing we really talked about is the sample space. What would the sample space be? And the best way to write the sample space is to write events that have the same chance of occurrence. So write out distinct events that have the same chance of occurrence. Does that make sense? All right, so if we wanted to write out the sample space here, what would it be? What are all the possible events? Be careful again, though, because of the way I have chosen to define the variable. All right. So it's to make sure whenever they say something like this, you know which variable they're referring to. Does that make sense? So what does this variable mean here? And then what are the possibilities? Does that make sense? That's You're really more or less answering the entire question, but the problem is you're not answering it based off the way I phrased it. Don't get me wrong. That's what we have to actually know, though. Okay. But the thing is you're not answering my question. And then maybe you get the answer wrong on the test. All right. So this says the number of heads, the number. Okay. What are my possible outcomes? Good. The only possible outcomes are 0, 1, and 2. You can either get 0 heads, 1 heads, or 2 heads if you flip 2 coins. Is that correct? But wait. Now we need what you said anyway, though. Okay. So xi could be one of these numbers, 0, 1, or 2. Those are the only possibilities. Does that make sense? Does everybody get what I mean by that? All right. The problem is I said write events that have the same chance of occurrence. Is that correct? Well, now I'm a little confused. Do these have the same chance of occurrence? Halo. Do these have the same chance of occurrence? You actually just said something previous to that says that actually details that they don't. The previous thing you just said before actually will make some of this not have the same chance of occurrence. What do I mean? One heads, you mentioned two different ways it could happen. Is that correct? All right, so now, first I'm going to write out all the possible events. Does that make sense what I'm saying? You said what they were already. You said you could get heads, heads. You could get heads, tails. You could get tails, heads, or you could get tails, tails. Is that correct? That means the sample space for this particular situation is really two heads, one heads, or zero heads. Is that correct? Does that make sense? That's a sample space. You understand why I'm saying that? Because those are the particular values that this thing could be. Is that correct? Right? And those particular events that I've labeled are equally likely. Is that correct? Right? Do you get what I mean by that? Hey, you just flip the coins, that's a possibility. You flip the coins, that's a possibility. You flip the coins, there's four possibilities. Is that right? Question? All right. The next thing that they want you to be able to do is write this thing called a probability distribution. Probability distribution is something that satisfies a few properties. Well, let's write out definition first, I guess. Probability distribution is we've already written something before when we talked about distribution. That was what? Frequency distribution. Is that right? And relative frequency distribution. And cumulative distribution. Is that correct? All right, so that cumulative frequency distribution. Probability distribution. This is a list of disjoint events whose union is the entire sample space. And their respective probabilities. Disjoint just means that the two things can't occur at the same time. So what do I mean by this? So like we can label these events. This is X1. This one we can call X2. This one we can call X3. That's X4 or whatever. 1, 2, 3, 4. Is that correct? You cannot get though this and this at the same time. HT and TH. Is that correct? We flip two coins. If we got heads and tails, we did not get tails and heads. Is that right? Does that make sense? So these events we say are disjoint or they cannot occur at the same time. Do you understand? Right? Or the probability that they occur is equal. Does that make sense? At the same time. All right, what am I doing? All right, so list of disjoint events. Okay, so the disjoint events that we would list in this case would be what? What are the different events that could occur? No, because be careful again. Again, this thing means X means the number. Does that make sense? So what are the different possibilities? We have to list out all possibilities. That's all this means, that the entire union just means or. Does that make sense? So if you take all of the possible events, it's going to give you the entire sample space. Does that make sense? So we have to list all possible events here that are non-overlapping. What are all the possible events? What will we list? 0, 1, and 2. So 2, 1, 0. Doesn't matter which order we write them in. I'm just writing them this way. Does that make sense? All right. Then what's the probability of this event? The first one. 25%. Don't say 25 because 25 can't be a probability. Does that make sense? I'd rather you write a fraction. You understand? 1/4 is correct though. All right. This event 2, that would mean A is this. Is that right? Right? That's my A. So there's one thing favorable out of 4 equally likely events. Does that make sense? Therefore, it must be what you said, 0.25, or if you want to write this as 25%, it doesn't make any difference. Does that make sense? Decimals are worse though, okay? Fractions are much simpler with this. Does that understand what I'm saying? All right. 1, what's the chances I get 1 now? What's it? So they'll ask something like this. What's the probability the random variable will be equal to 1? Does that make sense? And then maybe they will try and write this in some funky way. They start writing like P X I equals to 1, something like this. People get confused to shit. Does that make sense? All right. Go ahead. 1/2 is correct. There's 2 favorable events now. Does everybody see that? Does that make sense? Does that make sense? 2 favorable events out of the 4 total. Is that right? Question, Lucas? 2 right here, these guys. What's the chances you're going to get 1, right? Well, it could have been, could have got 1 here. Could have got 1 here, right? That's good. Well, if I flip the coins, these are the only possibilities there. Okay? Right? So 2, 1, and 1. Does that make sense? Yeah. So the only possible way we're going to get 1 is there's 2 ways we're going to get 1. Is that right? Then there's 4 total possibilities. Therefore, this is 1/2 is correct. Or of course, you could write that as 50%. I'm just going to continue writing the fractions though. Does that make sense? But do you understand why I'm saying that if these things are, it can occur at the same time, it's going to cause a little bit of an issue here? Because we don't want these numbers to be overlapping. Does that make sense? We just want to see the simplest things, what the probability is going to be, because then all I have to do is, if you say to me, what's the probability it's going to be 1 or 2? I could just add these things. Is that correct? Does that make sense? All right, what's the probability it's going to be 0 here? 1/4 is correct. There's one thing favorable in this case out of 4 total possibilities, right? 25%. Now this, if you did this correctly, right? This shit better add up to what? 1. Otherwise, we got a freaking problem. Does that make sense what I'm saying? Does everybody understand? So this better be 4 out of 4, and we get 1. Does everybody see that? All right, so then probability distribution. Now, these things that I'm about to say right now are not really, what do you call it? Like these are really consequences of what we're trying to do. All right, but there are some properties of probability distributions that you need to know. So property number 1. The probability of any event xi, no matter what it's going to equal to, this is going to equal to, this needs to be greater than or equal to 0 and less than or equal to 1. The probability of all of the events in the entire sample space must be equal to 1. Does that make sense? Does that make sense? All right. Then, see, I don't remember what your book writes. No, the book writes something really stupid. One of the things it says is I know that xi must be numerical. That's not really true in general, but what they're saying is they want these things to be numbers here. It's harder to calculate anything if they're not numbers. Does that make sense? All right. Then the other rule is that, like, if event A is a subset of event B, then the probability of A must be less than or equal to the probability of B. Does that make sense? If you say, what's the chances you're going to be blonde? Then I say, what's the chances you're going to be blonde or brown-haired? Blonde or brown-haired has to be at least as big as blonde. Does that make sense? There's just more stuff in here. Does that make sense? All right. I'll remember in a second what your book says for the rules, but this rule is not really a rule, right? This one right here. Okay. But in your book, it says that. So just remember that when you're answering the questions. Okay. So the stupid thing's not numbers, not a probability distribution, according to your book. Crap. What was the thing I was going to say? Oh, yeah. This is kind of bad. All right. So I asked the question before. I don't think I ever answered it. Can the probability be equal to 0 and the event still occur? And then the next one, can the probability be equal to 1 and the event not occur? And then, of course, whatever your answer is, I want an example. So can you give me an example of something where the probability would really be 0? Now you could do it. Make it happen. There's actually a there's a non-zero probability that if you flip a coin, that it'll actually land on the side. It's hard to do, but you can do it. I can make a machine that'll do it every time. Correct. Correct. So now I'm literally asking, like, if the probability is actually equal to 0. Oh, and the trick is, I'll give you a clue. Think of a sample space that is not finite. In other words, there's an infinite number of possible events. All right, that's the problem. That's the part that gets confusing in our head. All right. So the thing is that can the probability be equal to 0 and the events still occur? Well, if I'm asking the question, so always in a math class, if someone asks a stupid question like this, the answer is whatever opposite of whatever normal way anybody thinks. Otherwise, they wouldn't ask the question. Does that make sense? So in other words, the answer here is going to be yes. It's going to be possible. Okay. And then the answer here is going to be yes also. It's going to be possible. Okay. Otherwise, I wouldn't ask the question. Does that make sense? Because if it's what everybody already usually thinks, there's nothing to teach. Does that make sense? All right. So can the probability be equal to 0 and the event still occur? All right. Well, yes. Consider the probability of selecting 1 from all of the natural numbers. In other words, so let's say we have a data set, and the data set is, or the set of values is 1, 2, 3, 4, 5, 6, 7, 8, whatever. Keeps going forever. And then 1 is the one we want. Does that make sense? What would the probability of getting 1 be? The probability of getting 1 would be, well, 1 out of, right? I'm saying it keeps going. Infinity. Does that make sense? Then 1 divided by infinity, it's not exactly 0, but it is. All right? Not even though, because, like, I'm going to make it even bigger. the denominator. Does that make sense? And then you make the denominator bigger, and then you make the denominator bigger. So then it's just like, but you're right. It's like, oh, it could be 0.1. Oh, it could be 0.01. Oh, it could be 0.001. Oh, it could be 0.00. It just keeps going. Does that make sense? So then the only thing we can say is it's actually 0. Does that make sense? All right. So the chances here that this actually will happen is 0. But you could actually get it. It's possible. Does that make sense? All right. Could the probability be equal to 1 and it not occur? Yeah, kind of the same idea. Does that make sense? Effectively, now we just talk about the probability of not getting 0. Does that make sense? So then it would have to be, or not getting 1, sorry. This would be, this means probability of not 1. Okay? Well, then it would be like whatever the number of integers are here, which would be like n minus 1, all divided by n. Does that make sense? So it'd be like 999 over 1,000. Then it'd be like 9,999 over 10,000. This is going towards 1. Does that make sense? So this actually equals to 1 also. But again, there still was a chance that we got the 1 before. So it's actually still possible we're wrong. Does that make sense? All right. But if it's a finite situation and you have, if the sample space is finite and you have probability 1 or probability 0, then probability 0 means it cannot occur. Probability 1 would mean then it could occur. Does that make sense? Or it has to occur, I should say. All right. So what is the probability of an event that's certain to occur? 100%. Don't answer 100, but I would just say 1. Okay? They didn't even ask for a percentage, but you would 100% is correct. All right. What's the probability of an impossible event? We already said this. 0. A die with 6 sides is rolled. What's the probability of rolling a number less than 5? 2/3. So this is what? 1, 2, 3, 4, 5, 6. That's my sample space. The event of rolling less than 5 is this stuff. Each of these events are equally likely. So if I say xi is the value of a die after it was rolled, the probability that xi is less than 5 is the same thing as the probability that xi is equal to 1, 2, 3, or 4, right? Which then is 4 out of 6, which is 2 out of 3. Does that make sense? But again, it's easy if you can write out the entire sample space. Does that make sense? So at the beginning, that's what you need to do. All right? Just try and write out all the events. Does that make sense? And if it's not crazy, there's not that many, just keep doing that. Does that make sense? But later on, there's going to be stuff where you're not going to be able to write them all out. Does that make sense? All right, and then we're going to need a way to count them. Question? All right. Anybody question here? All right, refer to the table. All right, this question. This stuff pisses me off when I see this stuff. Because I'm like, when I was in school, if I saw this crap, I was like, thank you. I'm going to get it right. I see this on all these standardized tests, all kinds of different things. Does that make sense? Like, you need to know how to do this. And there's no way I can believe that anybody can't do it. All right. By the way, also, what I like to think about a lot when I do probability is I like to think it's just like the number of things divided by the total. Does that make sense? Number favorable divided by the total. Is that correct? Right? The fraction of events that are favorable. Further, the table which summarizes the results of testing for a certain disease. If one of the samples randomly selected, what's the probability that is a false positive? They tell you what it means right here. Does everybody see that? I'm not going to tell you when you take your test. Does that make sense? Does everybody understand? All right. What does this probability suggest about the accuracy of the test? Okay. First thing. Do you understand what I mean by false positive and false negative? What do you mean? It wasn't actually, they were actually pretty accurate. It was the problem is people don't know how to do them. But then they got better. But people got better. But that was really the problem. They're actually pretty freaking accurate. But if you do it right. So then they start telling you take it a bunch of times, because then if you screw up the first time, screw up the second time, hey, third time, we got you. Because if you test positive, yo ass got that shit. All right. So this is the important thing with these things. All right. All right. So what is this? So we can write this chart. Test outcome. I'll write it this way actually, because maybe it'd be more clear. Test outcome. Disease. All right, either the person has the disease or they don't have the disease. Either the outcome says positive or the outcome says negative. That makes sense? All right, so what's this? False positive, false negative, or neither? What'd you say? Neither. The test was accurate here. Is that correct? There's no error here. Does that make sense? Which one's false positive? Which one's false negative? Which one's no error? This is a false positive, is correct? Because the test came back as a positive, but the person did not show the property, right? Then this one. This is a false negative, because this is saying the person has a negative result, but they also have the disease. So that means you have COVID, but you didn't stick that thing damn far enough up your nose. You got me? And then this would be no error again, because this is correctly validating the outcome. Does that make sense? All right. So you should be able to tell me what a false negative is and a false positive. Does that make sense? All right. Interesting thing. So, like, I remember a few years ago when Obama was president, there was a recession going on and stuff like that. It's pretty bad, actually, in some places. Some of these places actually still haven't recovered, believe it or not. Alabama, I remember, like 50% of the people in the state were on food stamps. Okay? 50. That's a lot. All right. It's not much better now, believe it or not. All right. But that's a crap ton of people. Okay. Then they got all this problems with drugs and all this nonsense. So then people were turning around and they're being like, yo, we don't want to keep giving all these people money if they're on drugs, spending it on drugs. So we should drug test them. Government turned around. What the government said was not worth it. Well, a bunch of people in the government said, let's do it. A bunch of people in the government said it's not worth it. Does that make sense? You cheat the drug test. So then they're wasting all this money doing this, and then didn't make any difference. Drug addict knows how to cheat the stupid test anyway, do it every day. So that's what they do for their job. That's what they do for whatever, right? So they know how to do it already, right? You ain't gonna catch them. You're just gonna waste your money. All right. Or at least that's what they said. Okay. But there's an interesting thing when it comes to drug testing. Or any of these tests. Doesn't matter which one they are. I'm just using drug testing as an example. You can think of the same example with HIV testing, cancer testing. It makes no difference. All right. Which one of these things do we care about the most? If you're the person performing the test. So if you're the person who's going to perform the test, or you made the test, which means you got to sell it to somebody. Is that correct? Right? I ain't buying your shit if it doesn't work. Is that right? Right? No, wait, for real, right? Am I buying a dumb test if it's not going to tell me if I'm pregnant? No. What's the point? Okay. So which one of these things do we care about the most? Sorry? The blue. Oh, I'm talking about all four of them. Which one? So let's call this one, whatever. We named all this stuff already. You should be able to tell me what they are. So which one of these four things is the most important to the person giving the test? So let's first think about drug tests first. Okay. Who buys the drug test? You listen, I'm just saying, you go anywhere and you buy a damn drug test. No. No, I'm serious. No, you don't know what I'm about to say. You don't know what I'm about to say. For real. You go anywhere and you buy a drug test. Okay. What I'm talking about is for an employer. If an employer makes you purchase the drug test to be work at the place, you tell them, okay? No, you don't. Okay. Now that other thing you were saying, I see you. Anyway, so the thing is this if you are gonna do this though, the person is sitting here and they're going to be this corporation or whatever is purchasing these drug tests, right? What do they care about? Here, which one of these things? Why? I'm talking about drugs now. Sort of. If I sit there and I start saying false negative, but you're right, same thing. All right. False negative here, right? And that means you just came, I drug tested your ass, shit came back negative, but you on the drugs. No good. I just screwed up. I just paid for a test that didn't work. Does that make sense? So this better have a small chance. Otherwise, I ain't buying this crap. Does that make sense? Right? But then if you think about it, which I'm not going to explain, but if you think about it, this part here, you can't just always get things right. Does that make sense? So either you're going to get stuff wrong here or you're going to get stuff wrong there. Does that make sense? Well, I'm going to make the test so that this part is not going to be wrong very often. So you buy my shit. Does that make sense? But the more I make this right, this one starts getting worse. Does that make sense? You can't have both sides of the coin. Does that make sense? You understand? So then this, there's no cheating the system here. All right. You can't cheat chemistry. So false positive. All right. This thing here, though, if this one has gone up, this one has gone down in the probability. Does that make sense? And vice versa. So in other words, if we want to keep this one low, this one had to get a little higher. Does that make sense? What does that mean, though? If you're going to this company and you're getting this drug test, what does it mean? What does that mean? No. That they think you're on drugs and then you're actually not. So that means there's a bunch of people now, a lot of people actually, okay, who are going to come in there and they're going to say you popped it, you drug addict, and you're not actually on drugs. And then this crap, they're going to be really right about. There's going to be a very small number of people that are going to fall into this category. Does that make sense? And it's the same thing with an HIV test, same thing with a pregnancy test, etc. Like you were saying. So like you're not gonna go buy the damn pregnancy test. Oh, excuse me. So like if you take a pregnancy test, I sit there and I turn around and I tell you that you're not pregnant, but you actually are. This is a big problem. Does that understand what I'm saying? If I tell you you don't have cancer and you do, this is bad. Does that understand what I'm saying? You could die, right? Okay. If I tell you you have cancer and you don't, I made a mistake. I'm sorry. but you're gonna have a happy day in a couple days. Okay, you get what I'm saying? Like there's an error, and then there's a worse error. Does that make sense? What I'm saying? All right. So yeah. All right. Any question with this? There's some really nice math later on where you can start doing these types of things, and you can actually start showing what the values have to be and all this other stuff. All right, and how they relate to each other and all this other crap. All right, so refer to this table. It summarizes this crap. If one of the results is randomly selected, what's the probability that's a false positive? How would I do this? Good. Nope. You're right. You have to get the total though. You always have to get the total. Add them all up is correct. So what is that? This is 114. This is 120. 120 is 273, right? What do I put in the numerator? 26 is correct. These are the false positives. They're positive, right? The test says positive, but it's wrong. It's wrong. It's an error. Is that correct? Does that make sense what I'm saying? Indira, question? Does that make sense, guys? Or you just type in your calculator. Does that make sense? Question? What does this suggest about the accuracy of the test? Well, this is definitely less than 10%. 10% of 273 is like 9 point something. 9 point should be like 9.5%, something like that. So like the look maybe a little closer to 9.4 or something. Anyway, but this thing here, it's definitely less than 10%. 10% is 27.3. Does that make sense? Move decimal one place over. Is that right? So this is less than 10%. What does it suggest about the accuracy of the test? Um, so the thing is that there's something that's a little like stupid in stats a little bit, but what we said was that if something is like, or actually, I don't know if we said it yet, actually, but we say that something is unusual. That's correct. Is less than 5%. Okay. So like, if something is unusual, it's less than 5%. Does that make sense? This shit ain't unusual. It's freaking usual. Does that make sense? Or common. Does that make sense? You take a fucking test and then you sit there and you ask me if I'm pregnant, and then 10% of the time this stupid thing's gonna sit there and tell me that I am pregnant and I'm not. Yo, I'm gonna burn your store down. Okay. So like the this but this depends on what the test means. It depends on that type of stuff. Usually, yes. Okay. Better in terms of I'd rather make that error, but I'd rather just not make errors. You know what I'm saying? Like I don't want to screw up and tell you you're pregnant. You know what I mean? My wife's still gonna kill me. Okay. So like you know, I think I want to finish the semester, but the thing is like this, you get what I mean? All right. So but the thing is this gets a little annoying, but this is really important to think about. All right. So like unusual is less than 5%, right? So this thing's about 9 point something percent. How about 9% of the time you go and take your drug test at the job? They're like, yo, you're positive. You're a heroin user. Sorry? Don't tell them? Don't tell them? What the hell are you talking about? I don't know what drug test you're taking. But what? Wait. But the thing is I'm just saying, you go in a place, they give you a test, you get an outcome on the test, right? If you sit there and you get an outcome on these tests, and 10% of the time they're telling you you're a drug addict and you don't take drugs, this is really bad. Like, really bad. This is very inaccurate. Does that make sense? Because now, if the thing though was happening less than 5% of the time, then it's okay, sort of. Usually they say less than 5%. All right, but the thing is like 5% is just some like guideline type thing. So we use that when we don't understand anything else. There's nothing else we could say. I would like it to be less than 5% for this drug addict thing. Does that make sense? What I'm saying, right? Like I would like it to be way less than 5% for the pregnancy test. Nobody would buy these things otherwise. Okay, right? Like if you sat there and you knew a bunch of people and they go to the store and they take a pregnancy test and they're turning around telling you, hey, I took a pregnancy test a few years ago, it didn't work. Oh, I took another pregnancy test, it didn't work. Like people aren't gonna buy them. Sorry, no, this thing is super accurate. Super accurate. All right, so the but again, if you do it correctly, okay. But yeah, they're super accurate. All right, so you can't. Nobody's buying this shit otherwise. Doctor has to purchase this first, right? My dad used to be a gynecologist. Well, he is a gynecologist sometimes. So my dad's a gynecologist. All right. So when he this was before he started or whatever. But the thing was like when they first made these tests, the first thing they do is they try and sell it to the doctor, so the doctor can sit there and sell it to you. They're not allowed to sit there and sell it to the person directly. You don't know if the stupid thing's gonna work or not. I could con you into buying all kinds of stuff. Does that make sense? So it can't work like that. You understand? Um, Unusual, whatever. So if a person told you what month they were born, would it be unusual to guess the date of their birth? 12. Question 12. Read it again. Well, okay. I don't really care what the answer is. I always care about how we do it. Does that make sense? So what are you doing to answer this question? And I don't know if it is or it isn't, but oh, it has a lot to do with it. He said, I'm going to tell you what month I was born in, right? If I ask you what your birthday is, right? Nobody usually cares about what year you're born. Does that make sense? Right? Like, who gives a shit what year you're born? All right. So if I ask you what your birthday is, it's like, yo, my birthday's January 1st, right? Oh, now I'm gonna buy you shit on January 1st, right? So when's your birthday, right? That's what they're asking. Does that make sense? So then someone turns around and is like, oh, but if you knew what month they were born in, so I've given you some piece of information, right? Now, given the fact that you know what month they're born in, would it be unusual to guess the date of the birthday? In other words, guess the day. 3%? How do you get 3%? We got to be a little careful. You can't do 1 divided by 30. So which month would be the easiest possible month for me to guess your birthday? February. We should probably do 1 out of 28 or 29. Does that make sense? So I would say 1 out of 28. So 1 out of 28, the probability of this event has to be larger than that or equal. Does that make sense? Does that make sense? All right. So now 1 out of 28 is still around 3%. So it's still going to be, this number is still going to be less than 5%, right? Does everybody see that? Wait, I wrote this backwards. I'm sorry. The probability of event A is less than or equal to this number. This is less than 5%. Therefore, it would be unusual. Does that make sense? What's the easiest month if you guess someone's birthday? If I told you what birthday we were born in, the one that has the least amount of days. When's your birthday? What's the day? So April has what? January, February, March, April has 30 days. Does that make sense? That means if I don't know 22nd, right? I have a 1 in 30 chance of guessing that correctly. Is that right? So then which month would be right. The number. So then which guess your birthday, right? I gotta know April 20. They said you knew the month. You gotta read it. You gotta read it. Okay, so then the April 22nd. There's a 1 in 30 chance I'm gonna guess that correctly. All right, without knowing anything else. The what's the easiest month that we can guess your birthday though? Because that's gonna give me the highest chance, right? Because I want to see if it's gonna be unusual or not. Does that make sense? So February though is gonna be 1 in 28 if there was no leap year. Does that make sense? That's still less than 5%. So no matter which month I picked, it's gonna be unusual. All right. Frisky, I don't want to do frisky. All right. So in a certain town, 4% of people commute to work by bicycle. What is it? Odds. All right, odds. So we have to talk about something that's referred to as odds ratio. Odds ratio. This is like we write A to B, or we write A colon B or something like this. So then there's some sample space, and there's some events A over here, and some event B over there. All right. Let's say there's A many ways A happens, and B many ways B happens. So then we just say that the odds of A to B is equal to, we just write A divided by B. Does that make sense? So if there's 27 ways this happens, and there's 14 ways this happens, it's 27 to 14. Does that make sense? Ratio means fraction. A rational number is a number that can be written as a fraction. It's a ratio of two integers. Does that make sense? A rational function is a ratio of two functions, like f of x divided by g of x. So if I say a ratio, it really just means write a stupid fraction. Does that make sense? All right. So odds of A to B is this thing. Does that make sense? You could write this, you could write this, or you could write this. It's all the same thing. I'm just trying to make sure that if they say it in a question, then you can refer to it. Does that make sense? All right. So then this odds of A to B. All right. Sometimes people also write here this. This is generally the way I'm going to write it. Odds of just A. Does that make sense? This is the odds of A happening. What is the odds of A? So the way I like to define it is this way. By the way, I'm not like I like to define it. I'm not defining these things. I'm copying this from a book. Does that make sense? That whatever book I read when I was in school or something. All right. So then odds of A, right? Odds of A is equal to a fraction, right? It's the number of elements in set A, right? So this is just n of A, n of B. What you could think of this is also the number of ways favorable to the number of ways unfavorable. Odds of A, right? How many ways? What's the odds of getting a king? The number of ways you can get a king to the number of ways you can't get a king. Does that make sense? All right. Odds are not the same thing as probabilities. Okay. Probability divided by the total. Odds are not divided by the total anymore. So this could be like anything. Does that make sense? Any positive number or zero, right? Or infinity, I guess. Sometimes they start saying the odds against A also. This is the same thing as saying the odds of not A. I think in your book, well, whatever. Let's just write it like that. Therefore, the odds of not A is the number of ways B happens to the number of ways A happens. Does that make sense? If this is 27 to 14, now it's 14 to 27. Does that make sense? Question with this so far? You just switch it. Does that make sense? Because if we're saying odds against A, we want A to not happen now. If A doesn't happen, then B happens. Does that make sense? All right. The only thing is they don't call this B. This is referred to as the complement of A. Complement of A, we write this as like this. So I write this as this. This is means, all this means is not A. Does that make sense? So stuff where A doesn't happen. Does that make sense what I'm saying? So all you need to do is odds against A, count the ways A doesn't happen to the number of ways A happens. How do you count the odds for A? Oh, you count the number of ways A happens to the number of ways that A doesn't happen. Does that make sense? Favorable, unfavorable. Does that make sense? Question? All right, let's see. In a certain town, 4% of people commute to work by bicycle. If a person is selected randomly from the town, what are the odds against selecting someone who commutes to work by bicycle? Yeah, I'm not doing that. Stupid. No, it's not. It's a stupid question. Um, I put it on here because I wanted to do a different question, and they put a stupid question, so it's not worth it. In a certain town, 4% of people commute to work by bicycle. If a person is selected randomly from the town, what are the odds against selecting someone who commutes by bicycle? Oh, there's one other thing I can do. Sorry, I forgot to mention this. You can rewrite this formula here. The odds of A equals to, I just said the number of ways A happens to the number of ways that A does not happen. If I take this whole thing and divide by total on the top and divide by total on the bottom, now this top part is the same thing as the probability of A, and this is the same thing as the probability of not A. So in other words, you can relate the probabilities to the odds by this. Does that make sense? The ratio of probabilities. All right. Chances this happens, chances it doesn't happen. Does that make sense? Whenever you go to a casino or anything like that, they always tell you everything in terms of odds ratios. I sincerely believe the reason is so that people don't understand how easy it is to lose the game. They start thinking there's a better chance to win. If I tell you there's a 1 in a million chance that you win, or if I tell you there's 999,000 chances to 1 that you're going to lose, for some reason people like the 999,000 better, and they like play the game more often. Believe it or not. Sample space. Sample space. All right. In a certain town, 4% of people commute to work by bicycle. Come on. This is the third time I'm reading this stupid thing. How do we do this? If a person is selected randomly from the town, what's the odds against selecting someone who commutes by bicycle? Sorry? No. 4% doesn't have to do with 4 by 10, 4 out of 10. Also, 4 by 10 means 40. Does that make sense? What'd you say? Okay, you're closer, but you're making a mistake. You're not doing odds ratios. You're doing probability. Does that make sense what I'm saying? You're very close though. Mm-hmm. That's not gonna work here. I'll explain what that means in a second. I'll explain what that means. No, that's the probability. So Let's read the question here for a second. The probability of commuting to work by bicycle, right? Well, I'm going to just write bicycle here. That is 4%, right? That means the probability of, so I'm just going to call that B. The probability of not bicycle then would be what? 96 is correct, right? Because either you take bicycle or you take something else. Is that correct? So then the probability of the complement of an event is really just 1 minus the probability of the actual event. All right. We'll write that again in a second. But does that make sense? All right. So these things are probabilities. They want odds ratio. Does that make sense? So now they say the odds against bicycle, which really means the odds for not bicycle. Does that make sense? All right. How would I do that? I'm going to draw a picture in a second that'll make this make more sense, but I just wrote a formula. We should be able to do it. If you were paying attention. See, I know this is a hard question for people, but I'm telling you, it's all about your understanding of fractions. All right. So then this thing here, this, I'm going to just draw a picture to represent the sample space. All right. So when I was in school, I would sit here and get confused. And then I'd be like, what the hell? And then I'd be like, but I know fractions. I can do it. All they're saying is this is 4 out of 100 or something. Is that correct? Right? Sort of. Can't really assume it's 100 things. Does that make sense? But I'm going to pretend it is. So that means there's like 4 B's and there's 96 not B's. Does that make sense? Then there's 4% of the time you would take the bicycle. Is that correct? 4 out of 100. Is that right? Well, the odds of not taking the bicycle, then by definition, it just means count the number of not B's to the number of these things. So it's 96 to 4. Is that correct? Odds against. 96 to 4 is the same thing as 24 to 1. So that's the answer. Does that make sense? But the thing is that I have a problem with is I just wrote this formula right here. And I saw people not watching and not writing it down. And this is going to immediately answer the question. Does that make sense? Well, that's why I was trying to show it to you. All right. So then, because I know this question is hard, that's why I'm picking these questions, because I want to make sure I go over the ones that are the ones that people have difficulty with. Does that make sense? But we could have done it this way. If I say odds against bicycle, right? Then this means I could just do the probability of not bicycle divided by the probability of bicycle. But you guys all identified these pretty well. So that means you could have just written 0.96 over 0.04, and then you get the same thing, 24 to 1. Does that make sense? Doesn't matter that much, and I still want you to think about this here and be able to do this part here, okay? But at the same time, this is a helpful formula in this case. Does that make sense? All right. Determine whether the two events are disjoint. Draw one ball colored red from a bag. Draw one ball colored blue from the same bag. And they are disjoint. I can't draw one ball and it'd be both red and blue, assuming that the balls are all one color. They're trying to imply the balls are one color, though. Does that make sense? Does everybody see that? You can't draw one ball from the bag and it both be the red ball and the blue ball. Is that right? Independent means that one doesn't affect the other one. All right, we're going to do that. That's the next thing. No, this is not 24%. If anything, this is 2,400%.
Right, so how would you say?
24 to 1, 24, 24 colon 1. Because you remember it's A colon B. Does that make sense? or A divided by B. So this is A divided by B, or I could just say it's 24. No problem. All right, this is good here. All right, now we were talking about this complement thing, but I didn't write the formula. So let's write the formula. All right. So now the probability, so this is kind of good, I think, but the probability of event A plus the probability of event not A has to be equal to 1. Is that correct? Is that correct? Yeah, this thing I wrote right here is complement. Does that make sense? All right. This has to be 1. Why? Give me an example. Correct. So like if the chances you hit the baseball is like 30%, the chances you ain't gonna hit the baseball, it's gonna be 70%. Like what else is it gonna be? There's nothing else that can happen. Does that make sense? Either A happens or A doesn't happen. Is that correct? Does that make sense, guys? All right. So then, but then you could solve this equation for this thing. So if I subtract this from both sides, then you get this formula, I guess, that the probability of the complement must be equal to 1 minus the probability of the original event. Does that make sense? So what is this for? Is that sometimes in probability, like calculating the thing that someone's talking about is impossible. Like sometimes you can't. But sometimes I can really think about what is the complement of that event, and it makes more sense. And then I can calculate that probability. So maybe it's hard for me to calculate the chances you're going to hit the baseball, but then all of a sudden I can calculate the chances you won't hit the baseball. Oh, 70% of the time you won't hit the baseball. Great. Then 30% of the time you will hit the baseball. Does that make sense? So this is you kind of always have to think about like which one's easier, the complement or the regular event. Does that make sense? Question? Tanya, question? Based on meteorological results, the probability that it will snow in a certain town is this thing. Find the probability in a given year that it will not snow on January 1st in that town. $64.4, right? So then the probability that it will not snow is 1 minus the probability that it will snow, right? So that's 1 minus 0.356. Is that correct? So then you get what? It would be 65, but then that stupid thing is there. So then we have to get 64.4. Does that make sense? Either one is fine, really. Again, you have to be able to write all of them, though, because sometimes they're going to ask you for one, sometimes they're going to ask you for the other. If they ask you for a fraction, you put the percentage, they're going to mark it wrong. If they ask you for the percentage and you put a fraction, they're going to mark it wrong. Does that make sense? All right, but you have to be able to do it. Oh, and then sometimes they want you to do a rounded decimal also. Does that make sense? If you don't round correctly, it's going to get marked wrong. All right. Or probabilities. No, not necessarily. They're going to tell you. They have to tell you the way they want you to answer the question. Does that make sense what I'm saying? Based off the way this is answered, based on the way this is stated here, anything you want. Does that make sense what I'm saying? I would not write percentage unless they asked me though. But if the person answered this as a fraction and they told me I marked them wrong and I read the question, it didn't say they had to answer as a fraction, I go and give them credit. Does that make sense? I just need to know you're answering the question correctly. Does that make sense? All right, or probabilities. Which really just means doing a probability of a union. But union just means or, okay? So what is this garbage? This is, you should know about this my boy Venn. Like Venn diagrams are like the best thing to understand all this stuff always. Okay. So because that describes how you can explain what the sets are. All right. So let's say we have events A and B, and then there's some sample space. Does that make sense? What we want to know now is what is the probability of A or B? Do you know this rule? How do you determine the probability of A or B? Do you guys know? There's not a single person who didn't do this in school, at least like 6 times. College algebra, no. But like you do this like 20 times in school. It's not even funny. So I'm gonna do a special case first, okay? And then we're gonna do the whole thing. All right. This thing is very easy. All right. But it's extremely important. And sometimes it gets confusing to apply, but it's very easy to understand. Does that make sense? All right, so union or probabilities. All right, so first we're gonna do a special case. We're gonna do if there were disjoint events first. So I'm gonna write here, assuming we have disjoint events. All right. What does the picture look like if we have disjoint events? Something like this. They can't overlap. They can't happen at the same time. Does that make sense? All right, like I consider this like my house and your house or something like that. Right now, my house and your house are completely separate. This is like me and my brother or something like that. We got to share our room or something. But this part, like, is in the middle. This part, he don't come on my side. This part, I don't come on his side. Does that make sense? All right. So disjoint events. These are disjoint. Is that correct? There is no intersection. A intersect B is empty. Does that make sense? That automatically implies the probability of A and B must be 0. Does that make sense? But like really 0 now. No chance at all. Not even correlation. I don't like the word correlation. We're going to use that word here. So we got to define that later. All right. So like, don't use that word. Okay. So the correlation means like things are related to each other or something like that. All right. It's not, this does not mean related. This means cannot have, and means at the same time. Does that make sense? What's the chances you're a girl and you have brown hair? Probably not very high. All right. So then but do you get what I'm saying? But the person has to be a girl and it has to have brown hair. If it was impossible for a girl to have brown hair, there are none of those people then. Does that make sense what I'm saying? If like in this case, that's what this would be saying. Does that make sense? Right? It doesn't overlap. Does that make sense? If these are girls and these are people with brown hair. Does that make sense? All right. So disjoint events, yeah, whatever. All right. So if we have the probability of A or B, again, that symbol just means union, it means or. Does that make sense? Most of the time, honestly, I'm just going to write or. Does that make sense? What would this equal to? You have any idea? This one should be easy. So if you have things that are disjoint, that can't happen at the same time, how would you figure out the probability of the chances that either one of them would happen? I'm giving you a clue right here. So if I say, what's the chances that you go to Broward College or you go to University of Miami, and when there's some group of people, right? There's going to be some bunch of them that go to Broward. There's going to be some bunch of them that go to University of Miami, right? If there's 15% of the people that go to Broward College and there's 20% of the people that go to University of Miami, well, then there's going to be 35% of the people that go to either one of them. Does that make sense? All right. So this is going to be, again, this is only if they're disjoint. This is going to equal to the probability of A plus the probability of B. We just add them. Does that make sense? Because the number of things that are going to be favorable, I count up how many are over here, I count up everything over there, right? Divide by the total. Same thing as counting up here and dividing by the total plus counting up there and dividing by the total. Is that right? Do you understand? All right, now we have to say it in general. In general means not necessarily disjoint. Does that make sense? This picture then. Does that make sense? All right. Probability of A or B. Now again, not necessarily disjoint. Does that make sense? So I want to count up just all the crap that's going to be in here and divide by the total. Does that make sense? But I want to also relate this back to the probability of A and the probability of B. So I know I'm going to have to do something with adding. But this is not the right answer. Why? I'm counting this crap in the center here. Twice is correct. This stuff, if we just do this, you would double count. Double counts A intersect B. Does that make sense? The portion in the center. Does that make sense? Think about like carpet. So we're in this house. There's these two rooms. I'm like, yo, this is my room. That's your room. Our parents say we're gonna be able to put carpet down. I'm like, I'm putting green carpet. You're like, I want to do maroon. I'm like, but there's this part in the center. Like, what are we gonna do in the center? What are we doing over there? And you're like, screw you. I'm getting my maroon carpet. And you buy all this carpet. And then I'm like, screw you. It's gonna be green. I'm buying all this carpet. And we bought extra carpet. Is that correct? What are we gonna do? We can't put the both down here. Does that make sense? Does that make sense? So then the thing is I counted that part twice. Is that right? So if I want to get the right answer, I'm going to have to subtract that thing in the center because I just counted it twice. Does that make sense? Does that make sense? This is the rule. This rule always works. Sometimes this part is 0. Just 1 second, sorry. Sometimes this part here is 0, right? If it's 0, we get that formula. Is that correct? It will, but yes, but if this is 0 here, right? The intersection, okay? We would get this. Does that make sense? All right, they don't like the word disjoint. They want you to say mutually exclusive. Mutually exclusive doesn't exactly mean disjoint. Mutually exclusive does not mean this part right here. It only means this part. Does that make sense? It's not worth going through what the difference is for this particular course, but the mutually exclusive means this. Does that make sense? If that part's 0, then it would become this. Is that correct? Sorry, did you have a question? I'm sorry. But all you have to know is just this formula. Go ahead. Yeah, we're gonna use it in a second right now. It's easy. It's easy anyway. This is all over your book. I'm not saying anything special. Right? Like this is one of the sections in the chapter. Right? I have to show you there's gonna be one part in this chapter where the author's gonna write something and he's a freaking jerk. Like he's just a jerk. Like I can't believe you'd say something like this. Also, he seems racist. And he seems like a Republican, like a hardcore, like bad Republican though. Like not, I don't have any issues with people no matter which political party they have or anything like that. But You know, there's bad Democrats and there's bad Republicans, in my opinion. And but like, you know, some of these like racist types or whatever, it reminds me of that. I'll show you with examples from his book. But I'm like, why would you pick this example? Oh, because you're a racist. Why would you pick this example? You're a racist, right? It's like consistently happens. So like the one time he sits there and he makes fun of like Hispanic names. You know, it's I don't know. Anyway, so like a spinner has equal regions numbered 1 through 21. What is the probability? One time he sits there and he makes fun of the student when the student's reading the question. He's like, oh, blah, 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 blah. And then he turns around and he says, isn't that obvious? Well, it should be. You know, he says something like that. And he writes it in like big bold letters or whatever. And I'm like, what the hell? Like, just like ask the question. Like, get over yourself. Anyway, a spinner has equal numbers region 1 through 21. What is the probability the spinner will stop on an even number or a multiple of 3? Okay. So what do they mean by this? Spinner, like if you play like one of those board games and you flick that thing and it like spins around, you know what I mean? And then it lands on a particular number. Does that make sense? All right. So they're saying we have one of these and there's 21. Does that make sense? What's the probability the spinner will land on an even number or a multiple of 3? So I'm going to say even. I'm going to call that A. And then I'm going to write B is multiple of 3. Okay. Now, this means this is the same thing as saying the probability of A or B. I just don't want to keep writing that. Does that make sense? Now, immediately, we could just jump directly to the formula. The probability of A plus the probability of B minus the probability of A intersect B. That always works, I said. Does that make sense? I don't like doing stuff like that. Okay? If you constantly keep relying on the formulas, you're going to get them wrong, and you're probably going to tell me you don't know how to use them. Does that make sense? You should first try and think about it and see what you can do and get the answer. Does that make sense? All right. This particular thing, I'm just writing out the entire sample space to explain it to you. All right. You don't have to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, right? I'm going to highlight all the multiples of 3. Those guys. I'm going to underline all of the even numbers. You could also draw all this stuff in a set diagram if you wanted to. All right. Like in the Venn diagram, put them all in there. Does that make sense? Sometimes that's more helpful, to be honest. All right. I'm just going to do it as I would do it myself. Does that make sense? Then I'm going to do it other ways. All right. So if I was going to answer this question, what I always try to do first, if I think I can, or I think it's like easy, is I try to just do number divided by total. Does that make sense? Favorable divided by the total number of things. Does that make sense? Well, whenever you do this, actually, I don't care which question you're doing, always try to do the total first. Does that understand what I'm saying? If you don't know what the total is, you're probably going to miss shit you're supposed to count. Does that make sense? Try and figure out what the total is first. All right. Then start thinking about the number that's favorable. Does that make sense? Does that make sense? All right. So what's the total here? 21. That part's easy. Is that correct? All right. Now, what would I do? I would start looking at something that they've provided me, count up how many things are associated with that, and then just count the rest of this shit that's left over. Does that make sense? Does that make sense? So there's 21 numbers here, right? Great. If I divide by 2, I get 10.5. That means there's 10 even numbers because the last one's odd. that make sense? So there's 10 even numbers. Now all we need to do is count the numbers which are odd but not even. Is that correct? Odd, excuse me. Multiples of 3 but not even. I haven't counted the multiples of 3 yet. So I just got to count the multiples of 3 that aren't even. Is that correct? So that's what? 3, 9, 15, and 21. Does that make sense? So what's that? 4. Is that right? All right. I don't think that was really that bad. Does that make sense? But I wrote it all out. Now, if I made this bigger, maybe you would have issues writing it out. Does that make sense? Not really, though, because you could just divide. But maybe it'd be a little bit more confusing. Does that make sense? Say again? There's count the number of even numbers here. So there's 10, the ones that I've underlined. Then there's 4 numbers that are highlighted but not underlined. That are not underlined, yeah. 3, 9, 15, 21. Because it's multiples of 3. All right, so then this, if we chose to use the formula here, what's the probability of A? What's the probability of even? But be very careful again. Stop. You got to stop saying 10. Okay. 10 divided by. Right. You just got to remember always write the total because I can't stand it when people do that and they get it wrong. You're doing the right thing. Does that make sense? All right. 10 divided by 21. What's the chances that it's going to be a multiple of 3? Be careful. No, 21's right. 21's right. All right. But the thing is which 7 is correct. 1, 2, 3, 4, 5, 6, 7. Okay. But you see why you'd overcount now. Is that correct? Every single one of the ones here, here, and here, I counted them twice. Is that correct? So then it says subtract the intersecting portion. What's the probability of the intersection? We're done in a second. I'm sorry. 3 out of 21. That's the part that's both sets. Does that make sense what I'm saying? Which is a multiple of 3 and even. This is these numbers. So this is 3 out of 21. Is that right? 12, the 18, and the 6 is correct. So then this is 10 plus 7 minus 3 all over 21, right? 7 minus 3 is the 4 from before. Is that correct? And it better be, otherwise we got a problem. So we get this. Does that make sense? It's the same thing you just asked before. You count the 1, 2, 3, 4, 5, 6, 7. Multiples of 3. It's like 3, 6, 9, 12, etc. Does that make sense? Which numbers here are multiples of 3? Do you understand? Question? Which the ones that I've highlighted are the multiples. There's 7 of them. Does that make sense? That is all. Oh, wait, do this last one. This last one's easy. A 6-sided die. What's the probability of 3 or 5? 2 out of 6, 1 out of 3 is correct. These are disjoint, right? So this is just going to equal to the probability of 3 plus the probability of 5. We get 1, 6 plus 1, 6. Say one more time. Correct. Or you do, but it's 0. Correct. Good. That's I always want to do disjoint. You see what I'm saying? That's but you see, when I did this crap here, I was adding up disjoint things. The 10 and the 4. Does that make sense? When I was doing this, now I'm not. So then you're gonna double count stuff. Does that make sense? Have a good evening.